8 alternate roles for engineers. Hi, I'm Jonas Basarte and welcome to my channel. Welcome to Practical Electricity. All your hard-earned work during engineering school finally paid off. But what to do next after passing the board exam? And while you're taking a long vacation with your college batchmate, or while riding on a huge Ferris wheel at Disneyland, Singapore, did it come to your mind the following questions? Number 1. What possible role I will be in when I get the job? Number 2. Are you going to be happy if you don't like the role? At this moment in time, everybody was expecting you to land a very good job. Eventually, everybody can get a job in order for us to survive and do it for the rest of our lives, 8 hours a day, 7 days a week, for some instances up to the time we retire. Upon passing the board exam, we must prepare ourselves to enter into the real world. We must become responsible as we should be. We must be certain with our decision because eventually it will lead you to the thing you know you want for yourself in the future. You will have the time to discover what is good and what is bad for you while pursuing onto your dream. So don't worry, if you feel lost, the space is wide enough to do the trial and error. Enjoy and discover more fun and follow the trail. So enjoy and start making things happen. Engineering career cover a wide range job role. All you have to do is to explore the different career path and find a role that suits your passion. Engineering career does not only focus on design. While engineering gives you the tools to do just that, it can also give you a variety of other positions or other options. Here is a list of alternative engineering roles you can select or you can comfort working in the future. Number 1. Design engineer. Design engineer is a person who may be involved in any of various engineering disciplines including civil, mechanical, electrical, chemical, textile, aerospace, nuclear, manufacturing system, and structural or architectural. Design engineers tend to work on a product and system that involve adapting and using complex scientific and mathematical techniques. The emphasis tends to be utilizing engineering, physics, and sciences to develop solutions for society. Design engineers may work in the team along with other designers to create the drawing necessary for prototyping and production, or in the case of building, for construction. However, with the advent of CAD and solid modeling software, the design engineering may create the drawings themselves or perhaps with the help of many corporate services providers. The next responsibility of many design engineers is prototyping. A model of the product is created and reviewed. Prototypes are either functional or non-functional. Functional, or what you call alpha or prototypes, are used for testing. Non-functional prototypes are used for form and fit checking. Number 2. Cost and planning engineer. Cost and planning engineer concern themselves with to get a particular job done. It organizes people, equipment, and procedure in an appropriate way to get a project completed in time and with budget. The main responsibility is to figure out and plan the best and most efficient way to complete a project, which means from beginning, planning engineers are involved. The techniques ensure that organizational objectives and system objectives are met in a timely, accurate, relevant, and complete way. It provides the adequate control of people, resources, and procedure, and clearly identify the tasks that must be completed and the desired completion time. Development Phase 1. They create plans and schedule to figure out what material and equipment will be needed, as well as estimate the expected amount of labor in terms of people and cost. Also, they often calculate the projected overall cost of the project as well as the timeline for completion. Planning engineer is expected to do but limited to the following. A. Study and understand the scope of work from drawing, BOQ, and specs in order to prepare the program of work. We call it program of works using project management tools such as Primavera and MSP. B. Generate weekly, monthly progress report. C. Generate executive report for the management. D. Prepare cash flow, time-bound cost. E. Analyze time overrun and cost overrun. Generally done by cost engineer in a big projects. F. To keep track of the project and flag the concern during shortfalls. G. Prepare look-ahead plan for the execution team. H. Cross-functional coordination to ensure smooth running of the project. I. Earned value analysis and management. J. Notify the clients or client's representative in change of scope. K. Get extension of time in case of reservation or entitlement. L. Forensic analysis. M. Maintain risk register in order to foresee the possibility of occurrence and take corrective action in conjunction with the project manager. N. Act as a wingman or body to the project manager throughout the course of the project. O. Prepare microplan for any particular work package. P. Chair the progress meeting and track the outcome and deliverables. Q. Maintain events record which shall be helpful in claims. Number 3. Quality engineer. The discipline of engineering concerned with the principles and practice of product and services quality assurance and control. All engineering systems needs rigorous quality check to ensure the process and product that result from them are of consistent and high quality. This is the quality engineer's rule. These professionals monitor the quality of processes in the variety of industries and play a key role in fixing any defects. A quality engineer is responsible for making sure that engineering and manufacturing processes are performed correctly using the right tools, materials, and processes. An important part of the job involves designing the company's quality standard and testing processes against those criteria. In most organizations, the QE also checks the employees are trained to the right quality standard and all the safety requirements are met throughout the production process. If anything goes wrong, it's the quality engineer's job role to meticulously document the problem and work with other engineers to find solution. These checks are essential not only to meet the client's requirement but also to satisfy legal demands in most industries. Some QEs work shift and are on their feet all day while others are desk-based and spend their days reading printouts of data. Quality engineers typically are part of the larger team tasked with making quality improvement across all aspects of production. Number 4. Site engineer. A site engineer offers advice in the planning, coordination, and supervision of technical aspects of construction project. A site engineer role is vital to construction project. They have a number of responsibilities including solving technical issues, providing advice, management, and preparing reports. Site engineering plays an important role in implementing construction projects. It is the key element needed by the property owner, investors in any development task. Hiring site engineer services is the best solution for managing construction projects. It guarantees that investments are utilized properly in producing the perfect quality needed for a successful development job. Site engineering, also known as construction site engineering, is responsible for the administration and quality control of the development project from the design stage to completion. Site engineer performs the job of the day-to-day construction site manager and they serve as the main source of technical information and quality control decision for the whole construction team. Its duties includes the following. Number 1. Making sure that the development project is built according to the construction plan. Number 2. Responsible for recording and maintaining all technical documentation of the development project. Number 3. Implementing and maintaining the safety standard of the construction. Number 4. Processing of daily site information such as submittals, RFIs, and shop drawings. Number 5. Reporting site progress and providing work details to the consultant and owners. Number 6. Coordinating with the contractor and subcontractors. Number 7. Conducting site inspections. Number 8. Maintaining quality control and monitoring the performance of the contractor and subcontractor. Number 9. Undertaking surveys. Number 10. Ensure that the project meets the estimated budget and deadlines. Number 11. Supplying on-site decision and technical advice. Number 12. Responsible for purchasing and negotiating supplies and material prices. Number 13. Planning site activities and creating site schedule. Number 14. Interpretation and implementation of construction designs. Number 5 is safety engineer. It is an engineering discipline which assures that engineered systems provide acceptable levels of safety. It is strongly related to the industrial engineering or system engineering and the subset system safety engineering. Safety engineering assures that a life-critical system behaves as needed even when components fail. Safety engineering also is the key component for eliminating hazard that would otherwise be controlled by either administrative control or use of personal protective equipment as a barrier between hazard and the workers. This engineered safeguard includes machine guards, selection of less hazardous equipment, development of maintenance procedure to ensure equipment safety, audit and inspection procedure, selection of safer tools, safety review of new equipment, employee maintenance training, safety design of the flow of materials and people through the facility and risk analysis for both possible man-made and natural incidents. Safety engineer design concept includes all environmental aspects of the workplace such as lighting, noise levels, atmospheric contaminants, ambient and localized temperatures, extreme, sleep resistance of flooring materials, emergency escape and routes, and fire suppression and alarm systems. Number 6. Sales engineer. Sales engineering is a hybrid of sales and engineering that exists in industrial and commercial markets. Buying decisions in this market are made different than those in many consumer contexts, being based more on technical information and rational analysis and less on style, passion, and impulse. Therefore, selling in this market cannot depend on consumers' type sales method alone, and instead it relies heavily on technical information and problem solving to convince buyers that they should spend money on the seller's product or services in order to meet business need, that is not to satisfy a business case. Sales engineer is thus both a salesperson that understands and can apply engineering, and an engineer that understands how to sell engineered system. They thus not only sell but also provide service and support. They provide this service to the various internal or external customer, and they may work for manufacturer servicing its industrial account, business-to-business customer, or for a distributor which is turn services the industrial account, business-to-business customers, or for the third party such as an engineering consultancy or a system integrator. Sales engineering is different from traditional sales rule. The system and technology that a sales engineer sells are often complex and expensive. Traditional sales and strategy, including closing techniques, do not typically work and can even hurt a sales. As technology advances, so must the sales strategy as a sales engineer. Number 7 is material engineering, or what you call logistic engineering. It is a field of engineering dedicated to the scientific organization of purchases, transport, storage, distribution, and warehousing of materials and finished goods. Logistic engineering is a complex science that considers trade-off in component system design, repair capability, training, spares, inventory, demand, history, storage, and distribution points, transportation method, etc., etc., to ensure that the thing is where it's needed, when it's needed, and operating the way it's needed, all at an acceptable cost. Logistic engineering as a discipline is a very important aspect of systems engineering that also includes reliability engineering. It is a science and process whereby reliability, maintainability, and availability are designed into product or system. It includes the supply and physical distribution considerations above, as well as more fundamental engineering consideration. Logistic engineering work with complex mathematical models that considered elements such as a mean time between failure (MTBF), mean time to failure (MTTF), mean time to repair (MTTR), failure mode, and effects analysis (FMEA), statistical distribution, queuing theory, and a host of other considerations. For example, if we want to produce a system that 95% reliability or more improved system to achieve 95% reliability, a logistic engineer understands the total system reliability can be greater than the least reliable subsystem or component. Therefore, our logistic engineer must consider the reliability of all subcomponents or subsystem and modify system design accordingly. If a subsystem is only 50% reliable, one can concentrate on improving the reliability of that subsystem design in multiple subsystems, and parallel in the case would achieve approximately 97% reliability of that subsystem. Purchase and store spare subsystem for rapid changeout. Establish repair capability that would get a failed subsystem back in operation in the required amount of time, and or choose any combination of those approaches to achieve the optimal cost versus reliability solution. Then the engineer moves on to the next subsystem. Number 8 is management engineering. Management engineering focuses on basic industrial engineering skills. Observation, data collection, and statistical analysis play a vital role in any project. ME serve as a facilitator and technical advisor for project ranging from staffing level to new information system technology, combining communication skills with a strong technical background. This project can include workflow design, scheduling of staff, organizational structure, workload management, interdepartment coordination, work method and procedure, defining workplace needs, and designing physical workplace layout, designing questionnaires or other data collection tools, statistical, mathematical, or graphical analysis, cost-benefit analysis, design or implementation of departmental or hospital-wide information system, developing system to monitor the performance, cost, and effectiveness of operations, and analyzing the alternative solution for using computer simulation. Those are the 8 alternative rules for engineering. Whether you are licensed or not, depending on your passion, you can be in one of them. If you know alternative rules for engineering, please write on the comment section below so we can discuss it on my next video. Thanks for watching.